Falcon 9.
It is January 7th, 2018 at about 7:46 p.m. local time at the launch site, or almost 1 a.m. Universal Coordinated Time on January 8th. You are looking at a live view of the Falcon 9 rocket as it awaits liftoff from the Space Launch Pad approximately 14 minutes from now. Welcome to today's live webcast of the ZUMA Mission from Launch Complex 40 at Cape Canaveral Air Force Station. My name is Brian Malstead, and I'm a software engineer here at the headquarters in Hawthorne, California. Now, today's primary mission is ZUMA, a payload built by Northrop Grumman, and per our customer's request, we will conclude coverage of the primary mission just following separation of the payload fairing. However, we will also show secondary mission coverage as we attempt to land and recover another first stage back at Landing Zone 1. Now, today's launch will mark SpaceX's first of the 2018 calendar year. We wrapped up 2017 with 18 total launches. This is the most that SpaceX has ever done in a single calendar year. Now, ZUMA was originally slated to launch from 39A a few miles north, but that pad is currently undergoing preparation for the launch of Falcon Heavy, so we moved ZUMA a few miles south to SLC 40, Space Launch Complex 40. Having these two operational launch sites on the East Coast with enough commonality for swaps like this is very beneficial. Now, it is important to remember that SLC 40 was designed long before the days that Falcon ever first flew. So over the past year, we have not only rebuilt SLC 40, but we have customized it for SpaceX purposes. This includes upgrading it to reinforce its structures, improve ground-side systems, and just in general, make it so that it can replicate the operations that are occurring up north at 39A. Now, together with 39A and 40 and Vandenberg on the West Coast, SpaceX now has 3 operational launch sites across the country. Now, having more launch sites means more opportunity for launching, which in general is beneficial because it increases our chances of higher launch cadence. Now, ZUMA, the payload, was mated to Falcon 9, the launch vehicle, some time ago, and all of those pre-launch integrations occurred in the hangar, which is just adjacent to the pad that you see on screen. All of this integration happens while the vehicle is horizontal, and while it's mated to that transporter or erector, or as you might hear us call it, the strongback. And that is done horizontally so that we have ease of access, so that we can work on the vehicle without having to go up very high. Now, once it's ready to roll out, as we call it, the transporter erector lives up to its name and transports the vehicle out to the pad and erects it into the final configuration for launch that you see on your screen right then. Now, once we're vertical, we're over 20 stories tall. Now, the first stage takes up about the first 2/3 closest to the ground, and then the second stage is that top bit with the fairings that encapsulate ZUMA. Now, we stage the rocket for the same reason that we want a better gas mileage vehicle. If you're carrying around less mass, your fuel is going to get you farther. And so because the vehicle, the rocket, is mostly structure, and within that structure is mostly propellant, once you use all that propellant, you don't need to carry around that empty structure anymore. That's exactly what happens. Once Falcon 9's first stage is nearly depleted, it heads back to the launch site after separation, and second stage then has less mass to carry on as it goes to deliver the payload to its final desired orbit. One of the most important procedures that we are conducting during this pre-launch phase is the loading of propellants. And we say propellants, we actually mean fuel and oxidizer, two critical components that are required for combustion. Now fuel, as you've heard us say before, for the vehicle is RP1 or rocket propellant 1. That's basically just rocket grade kerosene. The oxidizer is oxygen itself, and oxygen is typically at a gas phase when it's under standard atmospheric temperature and pressure. Now we supercool it to the liquid phase so that we have higher density. Higher density means more mass in the same volume, which for us means more oxidizer within the same rocket. So we're loading propellants. We load those fuel first and then oxidizer, first stage first and then second stage second. So that is currently underway. We started about 50 minutes ago and it's still going on and won't conclude for another few minutes here, but that is going well. Two other things we like to check before launch are the range and weather. Now, the range is responsible for all sorts of ground infrastructure, from tracking systems to clearing airspace, naval space, and ground space. They have given us the thumbs up, and the range is green for this ZUMA launch. Weather is not under our control, but all of the inclement conditions that Florida sometimes provides are not present right now. We don't have any upper altitude winds, no rain, and no lightning threats. So Florida's weather is green, so vehicle, range, and weather are all good to go for launch today. Now today is a 2-hour launch window, so should anything arise, we will resort to our backup launch window, which is tomorrow at approximately the same time. Northrop Grumman, the manufacturer of today's payload, is one of the nation's leading aerospace and defense companies. They've made stuff in market sectors from airplanes to software to satellites to electronics and even some other technical services. Now, some of their best known products you may have heard of include B-2, the Global Hawk, and the very recent and very famous James Webb Space Telescope. Northrop Grumman is over 66,000 employees strong, and they work across the nation with a bunch of mission partners to fly stuff just like today's mission, ZUMA. Now, they've been in the industry for over 50 years, so they have tons of experience, and their space missions include Earth observation, missile warning systems, defense, even protected global communications and other space science and exploration endeavors. Some of their recent, particularly space missions include Aqua, Aura, a space-based infrared system, other tracking and surveillance systems, Milstar you may have heard of, advanced extra-high frequency communication systems, and the Chandra X-ray Observatory, among many others.
We've all stared at the stars with wonder in our eyes, searching the sky for something more, searching the world for what else is out there, and wondering what we could do to find it. At Northrop Grumman, that wonder is more than just a daydream. We made it our passion.
Tranquility Base here. The Eagle has landed.
We've cultivated a world of dreamers and doers, of pioneers and protectors. Our engineers have always pushed the limits of space, and we've revolutionized technology again and again. We see limitations as challenges. We see the unknown as something only undiscovered. And we system engineer beyond what's impossible, because we believe there's no such thing. Northrop Grumman has the finest teams in technology, always working to push forward. From scientific pioneering, to global service, to making history. Our teams strive for innovation every day. And we've never lost our passion, never lost our wonder for what comes next.
in these final moments before liftoff, the vehicle is undergoing something that we call engine chill. Now, as I mentioned earlier, oxygen naturally wants to be at a gas phase. We want to coerce it into the liquid phase, and to do so, we need to supercool it. Well, that oxygen becomes very, very, very cold, and the engine is not as cold as the oxygen that will flow through it. So in order to reduce any thermal stress that might be imposed upon the engine, we try to chill the engine ahead of time so that we don't have as much of a thermal gradient. Now, you may remember we retract the strong back to around 50 degrees a few minutes before in previous webcasts. We're going to just prime the actuators and then retract it fully at T-0. In these final seconds, we're topping off the liquid oxygen, and then at T-1 minute, the onboard flight computers will take full control of the vehicle and transition it all the way from startup through terminal countdown. So let's listen into that now.
Stage 2 locks with close out for flight. Vehicles in self-line. Gas closeouts have started.
AFTS is ready for launch.
Falcon 9's in startup. Stage 2 tanks pressing for flight.
Falcon 9 and ZUMA are go for launch.
T-minus 30 seconds.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. Stand by for terminal count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Procedure 3.170 for bus cap Propellants. Vehicles prepared for launch.
Power and telemetry nominal.
And you see on your screen, we have had successful liftoff of Falcon 9 carrying ZUMA. We have cleared the tower, so we're now coming up on 2 events that is going supersonic and max Q. Now, maximum aerodynamic pressure is when we are at the point of maximum stress on the vehicle. From that point on, we're going through thinner and thinner atmosphere, so stress will continually decrease. And we've just passed max Q, so again, that means that as we ascend higher and higher, the atmosphere is thinner, and we do not need to have as much stress on the vehicle. Now, we're going to go through 4 events here in rapid succession, and those are in order: MECO, stage separation, SES-1, and the boost back burn. Now, MECO stands for main engine cutoff. That's when the first stage stops firing. There follows stage separation, when first and second stage depart from each other. SES-1 is the 3rd event. That stands for second engine start. That's when second stage begins firing. And then the 4th event in that sequence is the boost back burn. That's when first stage begins firing again to start its trajectory back to landing zone 1. Now that sequence will occur at about 15 seconds in duration, starting about 15 seconds from now.
Oh, 7, this is RC on countdown. Please relinquish control of the camera, please.
Roger. States have confirmed.
Stage 1 has entered its flight.
Now we've had successful confirmation of, again, MECO, stage separation, second engine start, and the boost back burn. Next major milestone is fairing separation. That should occur any second now. We're not going to show video coverage of it, but we will confirm that the fairings have separated, meaning that ZUMA and second stage are the only vehicles continuing on to their final orbit.
Stage 1 boost back shutdown.
All right, so we'll address the fairing deployment here in a second once we have more information, but for now, we're going to shift our transition back to the focus on the secondary mission, which is the landing and recovery of the first stage. Now, it is nighttime, so we're looking at a black screen, but we should be able to see some burning of the second and third burns here in the landing sequence. Quick sidebar, we did get successful confirmation that the fairings did deploy. So the primary mission has concluded up to this point successfully, and now ZUMA and second stage are continuing on to their final orbit. So we will focus back to the secondary mission now, which is this 3-burn phase of the landing of the first stage. Now, we already saw the boost back burn and got confirmation of that. The 2 remaining burns are the re-entry burn and the landing burn. Now, the second is the re-entry burn, and that is solely intended to decelerate the vehicle so that we go through the atmosphere subject to as little stress as possible. As I mentioned earlier, heat and pressure can accumulate. That thermal stress is very severe. As you go through the denser and denser atmosphere, you want to be going as slowly as possible. So we perform a re-entry burn just prior and during re-entry so that we have as little stress as possible on the vehicle. Now, that will happen at about T plus 6 minutes and 17 seconds, and that re-entry burn will last for about 15 seconds. We'll tune into that.
Stage 1 entry burn has started. And stage 1 entry burn shut down.
And as you just heard and saw, we had successful startup and shutdown of the re-entry burn, the second of 3 burns in the phase to get back to landing zone 1. Now the third and final one, as it is self-named, is the landing burn. This one lasts a little bit longer. It's about 17 seconds in duration. It's coming up in about 30 seconds. We should get pretty good footage of it coming down from the top of the screen. And again, that's a 17-second burn. So the legs deploy and we touch down on the surface of landing zone 1 here in this attempt.
Stage 1 is transonic. Stage 1 landing burn is started. Landing legs have deployed. LZ1, Falcon 9 is landed. Landing operator movement procedure 11.100 on RCR1 and LAB 2.
And the Falcon has landed. Now it was dark, but we saw some great ocular reflection as the heat and the light from the engine reflected off of landing zone 1, so you could see it as it deployed its legs and touched down. Now with the transition from the successful deployment of the payload fairings and the landing of the secondary mission, that first stage, we'll now conclude our coverage of this ZUMA mission. We'd like to thank our customer, Northrop Grumman. We'd like to thank the United States Air Force and the Cape Canaveral Air Force Station Range for all of their support in every single mission. We would additionally like to thank the Federal Aviation Administration for their part in regulating and licensing every single one of these launches. We would also like to thank you, the viewer, for tuning in as always. If you are interested in learning more about what we do here, please visit our website, spacex.com. And if you're interested in joining our force, spacex.com/careers. Please look for updates on all of our social media channels. We're going to post updates regarding the upcoming missions. Thanks again for joining us, and we'll see you next time.